Good afternoon, class. This is Chemistry Life class, and today we'll be considering rates of chemical reactions. I'm sure we are familiar with chemical reactions. Chemical reaction is reactants moving to products. That means it's a chemical change that involves substances undergoing this change in order to form new products. The starting species is called reactant, while the new product forms are called the new substance form are called the product. That means you can have A plus B to C plus D. To the left hand side are the reactants, right to the right hand side are the product. And these are the products. And there are several reactions. You have addition reaction, substitution reaction, you have elimination reaction, you have thermal reaction that involves heat, and a whole lot of reaction. You have double decomposition reaction. And to write reaction, you write it using equation. So today we'll consider the rate of chemical reaction. As the word goes, rate. That means the duration, how long or how slow, how fast these reactions take place. Have you ever wondered why 1 kg of rice, 1 kg of beans, this will take more time to cook than rice, regardless of them being the same quantity? Reason why? Because there is difference in their rate. That means there's difference in rate of reaction. Also, 1 kg of, let's say, chicken, and you decide to put it in the refrigerator, and another 1 kg of chicken you buy it from the market, and then just drop it in your kitchen, you will notice that this one will get spoiled before the next day, whereas this will take as long as months without nothing happening to it. Why? Because the rate of reaction differ. Unlike this, the rate of reaction, the rate of deterioration would occur speedily. But because this is introduced to an atmosphere of low temperature, the rate would reduce. That means we've established the fact that rate of reaction differs. Now let's define rate of reaction. So rate of reaction. Rate of reaction is the number of moles of reactant converted or product formed by unit time. So rate of reaction is the number of moles of reactant converted. Don't forget I said to the left hand side you have the reactants, which are the reacting species. So they'll get converted, undergo chemical change in order to form products. So number of moles of reactants converted or products formed per unit time. Per unit time. So we can say rate is equals to the concentration of reactant or product over time taken. That means you calculating rate of reaction involving concentration. You can also calculate rate of reaction involving mass. So it will be the change. This is the change, right? So rate would also mean change in moles of either the reactant or the product over time taken. And if you consider gaseous state, that means you're talking about volume, right? So rate can also mean change in volume over time taken. Change in volume, change in moles or change in reactant will be the difference, right? Time taken will be the duration. And we know that time is calculated in seconds. Concentration is calculated in mole, molarity. This is calculated in mole. This is calculated in dm cube. So this is mole over time. Time will be seconds. Dm cube over seconds. Let's take like 2 questions to buttress that point. And so let's take, in the reaction, hydrogen plus iodine giving hydrogen iodide. If the concentration of HI increases from 0 to 0.001 mole per dm cube in 50 seconds, what is the rate of the reaction? So from the question, we are told the initial concentration and we are told the final concentration, and we are also given duration. And we know is that is the change in concentration, right, over time taken. So let's calculate that. Since time is already in seconds, so we can calculate it straight to be rate equals to final concentration minus initial concentration. Since we are talking about change, so it will be final minus initial over time taken. The time taken is the duration. The final concentration here is 0.001. So it's 0.001 minus initial is 0. So this is 0 over time taken, we have 50 seconds. So it's going to be 0.001 minus 0 will give you 0.001 divided by 50. Let's punch this in our calculator. All right, so it is 0.001 divided by 50, and that's 2.0 times 10 raised to power minus 5. And the unit would be what? You know, for concentration, the unit is molarity, which is mole per dm cube, right? And time is seconds. So this is saying mole per dm cube multiplied by, or if you bring this up, right, it will be 1 over seconds, right? Since you bring it up, since it's divided by, it will be 1 over seconds, and this would be mole per dm cube per seconds. Hope we are clear on that. Can we continue? Any question on that? All right. You have a question? Go through what? Is it the solution or? All right. We are considering rate of reaction, right? And rate of reaction, by definition, is the number of moles of reactant converted or product form per unit time. In terms of concentration, it will be the change in concentration over time taken. In terms of mole, it will be change in mole over time taken. In terms of volume, it will be change in volume over time taken. The question here is, if the concentration of HI increases from 0 to 0.001 mole per dm cube in 50 seconds, what is the rate of reaction? From here, rate of reaction, since it is change in concentration, then it will be final minus initial, which is what I wrote here. Time taken, we're given in seconds. And since the unit to calculate time is seconds, so that's what is here. This minus this will give this divided by 50, and this is the answer we got. I'm sure we are good. We can continue. Let's try another question and then we move on to something else. Okay. So marble chips weighing 4.0 were dropped into a large volume of hydrochloric acid, 2.5 grams of the marble remained after 5 minutes. Calculate the rate of reaction. Okay, this is another question. Marble chips weighing 4 grams were dropped into a large volume of hydrochloric acid. 2.5 grams of the marble remained after 5 minutes. Calculate the rate of reaction. From this question, we are given the initial mass, right? So initial mass was 4 grams, right? The final mass 2.5 grams. Change in mass would then be 4 minus 2.5, and that will give us 1.5 grams, right? We're also given time to be 5 minutes. We all know that we cannot do the calculation with minutes because this is not the standard unit. Rather, we have to convert minutes to seconds, and we know that 60 seconds make 1 minute. So we multiply this by 60. And so 5 times 60 would be 300 seconds. So from here, we'll just basically do this change divided by the time taken. And so, okay. So rate then would be the change, which is 1.5 grams, divided by time taken, which is 300 seconds. So let's punch this. 1.5 divided by 300, and that is 5 times 10 raised to power minus 3. The unit will be gram over seconds. I'm sure we are good with that. Now, can I clean this first part? Yeah. Okay. Now we already know what rate of reaction is. We know the definition of it, and we know how we can calculate rate of reaction. Now let's consider factors that affect rate of reaction. Initially, I made mention there are different reactions. They take place by different rates. So the reactions do not occur at the same time. Rusting is a slow oxidation reaction, right? Lighting of match will take place almost immediately. Reactions like halogenation of alkanes would not, all right, I would entertain that in some minutes. Halogenation of alkanes will not take place except in the presence of light. So definitely there should be some factors that affect rate of reaction. And now we'll be considering factors affecting rates of reaction. Okay, what's your question? No. For that initial one I made mention of final, is basically change. And so for rate of reaction, the sign will be the negative. So what you are talking about is this negative sign, right? Right? Okay. So for this reaction, there was a decrease. For that reaction, there was an increase. And the way we are considering it, we are not considering the negative sign. It's just the value we are. Can I continue? Okay, thank you. Okay, so for rate, basically, it will not be negative sign. So the negative sign there was what I omitted. For that one, I had to explain it using final and initial. But generally, the formula is change in. And so for rate reaction, you wouldn't see the value having negative sign. So now let's move on to factors affecting rate of reaction. The first factor we'll be considering is temperature. The lady, can you please off your camera? Right, so that you do. How can I help her put off her camera? Oh, she's the only one that can off. She never answer me. Okay, so factors affecting rate of reaction. Let's start off with temperature. An increase in temperature will bring about increase in rate of reaction. That means at an elevated temperature, the rate of reaction will increase. It has been observed that a 10 degrees Celsius increase in temperature doubles the rate of reaction. Doubles the rate of reaction. So we can say for temperature is directly proportional to rate of reaction. Now let's consider another factor, which is concentration. Increase in concentration will bring about increase in rate of reaction. Increase in concentration will bring about increase in rate of reaction. Let's talk about using salt water to wash, let's say, snail. If to a bowl of water, you add just pinch of salt, and to another bowl, sufficient amount of salt, you would notice that to this it would wash off the snail well than using this water with just pinch of salt. Why? Because the concentration of the salt here is greater than the concentration of the salt here. And so we can say that increase in concentration will bring about increase in rate of reaction. So there are two now. We have temperature, we have concentration. This is directly proportional. This is also directly proportional. Let's consider another factor, and that would be pressure. Pressure. The factor pressure is peculiar to gaseous states. It's peculiar to gaseous states. So an increase in pressure will bring about an increase in rate of reaction. Increase in pressure equates increase in rate of reaction. Don't forget that pressure is only peculiar to gaseous states. So pressure does not have any effect on solid nor liquid in this case. And so we've mentioned three: temperature, concentration, pressure. Let's consider surface area. Surface area. And the factor surface area is peculiar to solids, right? It's peculiar to solids. An increase in the surface area, that means a wider surface area, would hasten the rate of reaction. That means it will increase the rate of reaction. Let's consider 1 gram of iron filling and 1 gram of iron nail. We know they are both the same, they contain the same composition. It's an element which is Fe, right? This is iron, which is a metal. Reaction involving this would be faster than this. Why? Because this is already in powdered form, and so it has a larger surface area than nail, which is just like this, right? This can be in a beaker, right? And so reaction involving this will take place fast. So for surface area, it's peculiar to solid. Increase in surface area will bring about increase in rate of reaction. The last factor, do you want to say something? What did you say? Illustration of the nail, is it the iron surface area? I said increase in surface area. For an enlarged surface area, there would be an increase in rate of reaction. Increase in surface area will bring about increase in rate of reaction. I said if we consider iron, which is a metal, Fe, 1 gram of iron filling and 1 gram of iron nail, right? They are both 1 gram. That means they have the same mass, right? But because this has a wider surface area, the rate of reaction will be faster here than this. Reaction like rusting. We know iron would undergo rusting when exposed to atmospheric air, but this would undergo it faster than this. Why? Because this has an enlarged surface area. So increase in surface area will bring about increase in rate of reaction. Are you clear on that? All right. So now let's move on to the last one, which is catalyst. We all know what catalyst is, right? Catalyst is a substance that alters the rate of reaction. Here, that means for catalyst as a factor here, increases the rate of reaction. Presence of catalyst in the reaction system would increase the rate of reaction. And how does it do? We are familiar with this profile, energy profile, which this would be reaction progress, reaction energy.